Hello, everyone. Welcome to the Carolina Weather Group. We welcome you to the Wednesday, November 28, 2018 edition of our little weather get-together. Tonight is show number 256, and we have with us Dr. Tracy Fanara. She is from Sarasota, Florida. She is a scientist at the Mote Marine Laboratory and Aquarium in Sarasota, Florida. She's also a graduate of the University of Florida. Go Gators. That's where I put my Go Gators in there right there. But anyway, we're going to be talking about the red tide tonight. I know it's kind of been a big story if you live here in the Southeast and if you vacation maybe in Florida or the Gulf Coast. You've heard a lot about the red tide. So we're going to get into that tonight, talk about what's causing it, the effects that it's having on the area, and maybe how the weather is contributing to the red tide. So if you have any questions tonight, please feel free to send them our way. You can do that one of many different ways. We're live streaming right now on Periscope and Facebook Live. We're also on YouTube, so you can submit those questions through those different outlets. We'll be monitoring those throughout the show tonight, and we'll make sure to get to any questions you may have. And if you're listening on the podcast version, we will let Tracy give her social media account out towards the end of the show. And that way, if you have any questions later on when you're listening to it, you can shoot those to her via Twitter. So again, we are happy to have you tonight. And this is going to be a very fun and interesting show. But before we get that, guess what, guys? It is November 28th. That means we are closing out finally the very active tropical season. Hurricane season comes to a close in about 2 days. And with that, I'm going to hand it over to Shay Gibson. And Shay's going to kind of give us, instead of a tropical forecast, he's going to kind of give us a review of what we've seen so far here in the United States.
All right. Thank you very much, Scotty. Let me go ahead and start real quick by sharing screen. Make sure you give me a cue when you see it. All right. Good deal. So we are winding down to the end of the hurricane season, which ends on November the 30th officially. And we can see here it's where the activity really scales down at the end of the month. And then as we get into the cooler months and the Atlantic waters cool all the way around, we see less and less activity, maybe a stray subtropical storm towards the end. But this year looks like we're going to finish out fairly quiet. The NHC does have nothing on its radar for the next 5 days. So we look good to go as we transition towards the end of the season. Upper shear is pretty heavy from west to east across the United States. We're seeing a succession of cold fronts and a lot of air, a lot of traffic moving across. That's at 500 millibars. We go a little higher up in the atmosphere, and we see even stronger winds. So that's another further deterrent between 18,000 feet and 36,000 feet. That's not going to allow any kind of tropical development to form. So I've got about 2.5 minutes left to wrap this up. Chris doesn't seem to think I can do it. So real quick, looking at the CDC, looks like nothing is on radar from them. Or I'm sorry, the CPC, nothing on radar from them as far as any forecast tropical activity or any areas of concern at this moment. Looking over the tracks for 2018, this is the preliminary report. It's not final. Nothing's going to be final till the end of the season. Then we're not going to even get information on some of these storms till possibly January. We had 15 storms this year, named storms. Last one was Oscar, which ended October the 31st on Halloween. The two most notable ones that we had this year, the two major hurricanes in the Atlantic Basin, which were Florence and Michael, both of them which made landfall along the United States, one as a major hurricane, one as a minimal category 1. We take a quick look at the tracks here you'll see in purple is Florence, and you can see where it originated from, way over here off of the coast of Africa. The other one, Michael, originating here in the Western Caribbean and heading north across the Gulf of Mexico and right into the panhandle of Florida. Florence, this is the satellite imagery from HERDAT, and we see the succession of where it began on September the 7th and all the way through to where it made landfall is a Category 1 90-mile-an-hour hurricane over near Wilmington, North Carolina. So you can see the satellite imagery there of what it looked like when it came to shore. But even out here on September the 7th, this was a Category 4 storm at 140-mile-per-hour winds. So the Carolinas really got a break on the system as it made landfall. The only problem was it was a major rainmaker. It was the first major hurricane in the Atlantic season, was a Category 4. Like I said, at one point over the Atlantic with 140-mile-per-hour winds. On September the 14th, Florence made landfall just south of Wrightsville Beach, North Carolina, with sustained winds at 90 miles per hour, central pressure at 958 millibars. The surge was estimated at being near 5 to 6 feet, but driving onshore winds piled up waters well inland of OBX and Cape Fear areas. Rainfall totals surrounded to 24 to 36 inches, with severe long-lasting flooding through South Carolina, North Carolina for weeks after the storm had passed, amounting to roughly 7.8 trillion gallons of water for North Carolina, 2.2 trillion for South Carolina. Due to slow progress of the storm, the watershed flooding caused rivers to crest to record numbers, including the PD River near Ansonville, North Carolina, at 35.6 feet. That's 2 feet above the 1945 record. Cape Fear River at 61.4 feet near Fayetteville, North Carolina, which is about 35 feet above flood stage. That was pretty significant. Also, records broken in South Carolina PD at 46.51 feet near Cheraw, 22.1 feet near the Waccamaw River at Conway, breaking the Matthew record of 19.1 feet. So other records were broken. We're still waiting for final analysis. Some of the analysis won't come out until probably January from the NHC when they do final accounts of these storms. Fatalities as of now, up to 56 people, with 42 in North Carolina, 9 in South Carolina, 3 in Virginia, and 2 in Florida from rip currents and drownings, along with 13 rescues down there. So widespread effects from that. You can see the flooding here. That was a major factor for most of this. I mean, we had, like I said, 24 to 36 inches of rain with a very slow-moving storm that went west and then north, and it just dropped a lot of rainfall, caused problems all the way up into the Northeast. Okay, let's take a look at another one of the notable pictures. Some of the fish here in North Carolina left over from ponding over interstates and highways. Let's see, North Carolina Public Safety Department has, let's see, it just has some stats here. Storm-related fatalities is up to 43, actually, instead of 42. And then you can see how many people they rescued and evacuated as well. So that was a pretty significant storm for the Southeast region. Taking a look at Michael, 2018, if we go back and look at the tracks, let me go back and look at the tracks here, if I can find it. There we go. Michael originated here just to the east of the Yucatan Peninsula, headed north across the Gulf of Mexico, and slammed into the panhandle of Florida. It slowly aggregated as it went north and rapidly intensified as it moved into a more conducive environment. And Michael was a strong Category 4 hurricane. Let me get the pictures up here. You can see where it began down here near the Yucatan and then headed to the north as it made landfall. Category 4 winds, 155 mile per hour. And that was on October the 10th at Mexico Beach City, Florida, with the storm surge estimated over 14 feet for some areas. It was the third most intense hurricane to make landfall based on pressure alone at 919 millibars. That'd be Labor Day storm being the first in 1939 at 892, Camille being second at 900 millibars. This was the strongest ever for the Florida Panhandle and the fourth strongest in U.S. for wind speeds. Death toll is reported at 60 as of now, including 15 deaths in portions of Central America where it originated due to heavy rains and flooding. So, you can see the damages here. It damaged land to a point where zoning will likely have to redefine property lines. I mean, estimated damages are roughly $14.58 billion for the U.S. and $100 million in Central America. So just the sheer amount of damages there is unreal. And I think I'm getting hailed by James now, but just to wrap it up real quick, this is the tracks right here for 2018, and I'll end it right there as a wrap for 2018 season as we head to the end at November 30th. Back to you, Scotty.
Thank you for that, Shay. We certainly appreciate that recap. I will say February 6th, we're going to have a representative from the National Hurricane Center on our show to kind of do a more thorough and more extended review of the different hurricanes. Shay did a great job there with the major hurricanes that affected us. But on February 6th, we're going to have a more in-depth look at what the National Hurricane Center's final findings are for the 2018 hurricane season. So with that, let's bring in our guest again. This is Dr. Tracy Fanara, and she is with the Moat Marine Laboratory and Aquarium in Sarasota, Florida. Tracy, welcome to the show. We're happy to have you this evening.
Thanks for having me.
You're welcome. And so we were talking before the show, you're not really in warm, balmy Florida this evening. It's kind of chilly down there as well.
Yeah, it is. And we're not prepared for it. I'm dressed like it's negative 30, but it's like 50. We're just not, I'm from Buffalo, but it doesn't count.
Yeah, once you get that Florida blood in you, you can't get rid of it. So we want to talk to you, and you have been doing a lot of research and a lot of information gathering on the red tide, and you made an appearance on the Weather Channel, which I saw, and I was like, we need to get Tracy on our show to talk about this. So first of all, we'd like to ask you, what is the red tide? What is this thing that's going on that a lot of us are hearing about. Maybe a lot of us outside of Florida don't really understand what the red tide is.
So Florida red tide is a common name for a species called Karenia brevis, and in large concentrations. So basically we get 70% of our oxygen from phytoplankton, but 1 to 2% of those phytoplankton are harmful, meaning that they can release a toxin that harms aquatic life. Florida red tide is one of those species. And what makes it so unique is that when that toxin is released, not only can it harm aquatic life, but it can also aerosolize. It can attach onto sea salt particles in the atmosphere, move on shore with winds, and cause respiratory irritation in healthy individuals. But for those with asthma or COPD, this can be very serious. So although, Florida red tide is specific to the Gulf of Mexico, phytoplankton is all over the world.
And so it has a lot of effects. So talk to us about the different causes of the red tide, and maybe what harms it brings, and maybe particularly what we've heard a lot about is the harm that it brings to the marine wildlife, and how has that been impacted in Florida? And maybe is there certain species that are more prone to this than others?
Okay, that's a lot of questions, but I will try. You got to remind me if I forget to answer one of them. So what causes red tide? Red tide has been around. We've had the earliest anecdotal reports of red tide in the 1500s by Spanish explorers. They were talking about red water and fish kills. We know that since NOAA has been recording Florida red tide, there has been one recorded pretty much every year since the 80s. So it is a native species. Naturally occurring, it occurs on the ocean floor, and with currents and upwelling, those blooms are brought to the top. And then with currents and winds, they are brought on shore. Now, if a bloom is close enough to shore to utilize surface water nutrients, it very well may to sustain or exacerbate bloom. So as far as what makes a bloom initiate, there are many different parameters. And honestly, we haven't had a consistent data stream or enough data to be able to answer a lot of questions about initiation that now we're going to hopefully be able to attack moving forward. So we kind of know the ingredients, but not exactly the recipe of that exact initiation. So it all comes into play with physical oceanography, biology, and water chemistry, all of it combined, and different factors or different ratios of different chemical makeups, biological makeups, and also those currents come together for an initiation. And the same thing with dissipation, except there's more to talk about that, and I'm sure that you'll ask that question later. But as far as how it affects the wildlife, so brevetoxin is a neurotoxin, and for us, it blocks our sodium channels and causes us to cough or sneeze, itchy eyes, itchy nose. For fish, it affects them the same way, but it suffocates them, and that's why they die in actually an intense bloom pretty quickly. Now, with the megafauna like manatee and dolphin, they're actually affected by ingestion. So dolphin eat fish that are affected by the red tide toxin, and manatee eats seagrass, and the toxin can accumulate on something called epiphytes that are attached to that seagrass that the manatee are eating. So in the necropsies that we've done with dolphin, for example, most of the toxin is found in the gut. However, it's found all over the body. It has spread to other organs, but the majority of the toxin is in the gut because it is through ingestion that they are affected.
I keep doing this. I've done this 5 years and I still forget to unmute my mic. So there has been some studies also that maybe the freshwater algae, maybe is it increasing the red tide? Kind of talk to us about the different types of algae blooms that you guys face there in Florida, and maybe how they kind of play off of each other.
Yeah, so we had a state of emergency in the state of Florida due to two separate red tide blooms, and they are very different species caused by very different things. So we know that Florida red tide harmful phytoplankton, starts on the ocean bottom, comes up to the top with currents, But freshwater cyanobacteria, that's a little bit different. Freshwater cyanobacteria blooms are a problem worldwide. We have problems with them in Lake Erie. For example, the city of Toledo had drinking water problems because a species of cyanobacteria called microcystis was found in their drinking water source, and the toxin was possibly in their drinking water. So this has been a problem worldwide. And the thing is with freshwater cyanobacteria is that a lot of it is preventable. Nutrients is a big factor in initiating those kind of blooms. And, we've done so much to change the water cycle. So naturally the water, it would rain, water would infiltrate through the ground and into the soil and, very slowly. Now that we have urbanized our land, what is happening is we're changing the water cycle. The water cycle rules the world, and we change it every time we lay any kind of pavement or pervious surface on the ground. And what happens is that water runs off really fast, high volumes, causing erosion, causing flooding, but also brings pollutants from pavements, from fertilizer, from grass, from agriculture, from wherever, and it brings it to our natural water bodies. A lot of people don't realize that every single drop of water that lands on the state of Florida ends up in our natural water bodies. And the more that we change that water cycle, the more those pollutants are going to get into our surface water without the natural degradation from biological, physical, and chemical factors that the natural water cycle allows. So the more we build, the more fertilizer we use, the more freshwater cyanobacteria blooms we will have. Now, there are over 2,000 species of cyanobacteria. There are marine species, there are freshwater species. The species that we had an issue with in Florida around the Caloosahatchee, St. Lucie, and Lake Okeechobee is called microcystin, the same thing that was in Lake Erie. It releases a toxin called microcystin. So they are two very different things. One's a cyanobacteria, so it is a photosynthetic bacteria. The other one is a phytoplankton. One is marine and needs very saline conditions. The other is freshwater.
Tracy, as folks in the Carolinas might be preparing for a beach trip this holiday season, visiting relatives, walking the beach, how can they keep themselves informed on where this is, and so they can plan accordingly during their trips?
It's a really good question. Because the Florida red tide bloom is very patchy, there are conditions constantly change. So the bloom moves with currents, but also depending on wind direction, you might experience respiratory irritation at one beach and you might not to a beach a mile to the south. That's why we at Mote Marine Laboratory developed the beach conditions reporting system in 2006 and then redeveloped it in 2015. So it shows beach conditions that anyone would want to know going to the beach from 37 Gulf Coast beaches, including those red tide effects like respiratory irritation and dead fish. So it's really important to check that. Our trained beach sentinels update that map twice daily. Another good resource is the NOAA Respiratory Irritation Forecast. It's a 5-day forecast, and it uses cell counts, including ones collected at Mote, in a forecasting model which uses winds and currents to forecast where the effects of red tide, such as respiratory irritation, might be experienced. Also, Florida Fish and Wildlife have a sample map, which you saw earlier. And that sample map shows the past 8 days worth of samples and where locations where they are high, medium, or low. So all of that information combined with satellite imagery gives you a pretty good idea of where the bloom is. And that beach conditions reporting system is really important because that actually tells someone at the beach what they're going to be experiencing, which is really important when making those decisions going to a beach. And to complement the beach conditions reporting system, we have CSIC, which is a citizen science smartphone application that allows anyone from anywhere to report beach conditions, including red tide effects, respiratory irritation, and dead fish, to fill in those blanks between BCRS sites and time, because those conditions can change regularly. So it's really important to stay informed.
So Tracy, Bernie Sabo, a viewer of ours that watches a lot of shows, kind of was tying into my next question. How does the weather affect the red tide? And more importantly, how does sea surface temperatures? I know that this kind of starts inland, but then it goes out into the Gulf and even some cases in the Atlantic. So how does the weather affect it, and how does the sea surface temperatures really affect this red tide?
Yeah, actually, red tide starts out in the ocean, but freshwater cyno does start inland. But so temperatures play a big role in any kind of phytoplankton. As far as Florida red tide goes, Florida red tide Karenia brevis does not act the same way in the natural environment that it does in a laboratory. And I have to preface what I'm about to say with saying that. But in laboratory studies, researchers have found that the sweet spot, or the ideal temperature range for Karenia brevis, is between 60 and 86 degrees. Now, that is a huge temperature window. However, a lot of people are asking the questions right now because our air temperature is beneath 60 degrees. Is that going to come into play and dissipate this current Florida red tide bloom? Which is a really good question. But the truth is that even though the air temperature might be below 60 degrees, it doesn't necessarily mean that the water temperature will be. In addition, Karenia brevis can exist throughout the entire water column. It is a dinoflagellate. It can move up and down. And so just because the surface water temperature might be below 60 degrees, it doesn't mean that the temperature 2 or 3 feet underneath it will be even. So today, for example, it was in the 50s in Sarasota, but the temperature of the surface water temperature of the ocean was still 70, 72 degrees. So it would take very long sustained periods of cold temperatures to have any possible effect. And then even then it's not, for sure that water temperature would completely dissipate a bloom. There's so many different factors that go into it.
And you talked about this a little bit earlier in one of the model runs, but how is NOAA, maybe in particularly the National Weather Service offices in Florida, how are they monitoring this? I've seen a post earlier, I think it was from the Tallahassee office earlier this morning, talking about the red tide. So how does NOAA and the local weather offices, what is their role or part in the red tide?
So NOAA does a lot of modeling and forecasting. So they take a lot of the data that we collect and FWC collects, other entities collect, and they put it into a model. So that 5-day forecasting model is actually a NOAA product. They're also working on, we are contracted on a project with them called HabScope. It's a cell phone microscope that allows citizen scientists to take a cell phone, it's literally a microscope with a cell phone on top of it, to the beach, take a sample of water, put it underneath the microscope. They upload a 30-second video of their sample. There's an algorithm in the app that they use to upload the video that can calculate the concentration of red tide based on its shape, size, and movement. That information automatically goes to a NOAA respiratory irritation model so that we can have real-time respiratory irritation results. And NOAA is the lead on that project as well. It's NOAA and GCOOS. So as far as weather goes, you guys were talking about the hurricanes earlier, and that's really important because a lot of people ask why this bloom was so bad. And there are quite a few answers to that question. So there's so many different things that come into play, like I said about initiation. But this year we had a number of things happen. For example, we had that Hurricane Irma, about a month before this hurricane bloom season started. So this bloom started in October 2017. Irma was in September. And so NOAA and NASA have made correlations between hurricane events and really long blooms. We saw this happen in 2004, 5, and 6 when we had an 18-month bloom. In the 90s, we had a 2-year bloom that was preceded by a hurricane event. So there is that connection. In addition, with this, with the winter, our winter was a little bit warmer, and then we had a lot of rain in our rainy season. So not only did we have that hurricane, we also had temperatures staying within the best range for Karenia brevis to exist. And then we had a rainy season that came in, bringing surface water nutrients to the coastal waters, where we already had an existing red tide bloom. And then because we had a rainy summer, it kept the Gulf temperatures a little bit cooler. So a lot of things coming into play, along with the Florida loop current, which in certain cases can be conducive for Florida red tide blooms, and this year was one of those cases. So there's just a lot of things coming into play.
Tracy, that's actually it's perfect timing, because that was going to be my next question, and I'm gonna share a screen so folks can kind of see what we're talking about. When we talk about the loop current, the loop eddy, and this is just a general. This sort of meanders a little bit. The loop current meanders north to south a little bit, but the eddy is pretty much there year round. Sometimes a little bit further to the south. And talk a little bit about bathymetrics. Like we're talking about underneath the water, where we have cool water underneath that is upwelled to the surface, and how that cool water and those growths down there, those organisms down there react with the organisms at the surface. When they're brought up from their environment to the top and they die, they are basically eaten by other organisms. So talk a little bit about how all this sort of begins, especially using the loop current.
Honestly, I'm not the best person to go into detail about the loop current. Bob Weisberg from USF is definitely the best person to talk about how red tide and the loop current are connected. At Moe Marine Laboratory, we really focus on the chemistry and the biology, along with the physical oceanography. I'm just not the best person to answer that.
No, sure, I totally understand. But I mean, you did bring up like active hurricane seasons, which that especially in the Gulf, when you get active hurricane activity in that area, that can tend to well up some of those.
So that's exactly what happens. It's like a forced upwelling event where that bottom water is taken to the top along with those cells and nutrients, and that's how that's what's thought to start that initial red tide physical aspect of the bloom.
Right, especially with Irma. You brought up Irma because those were offshore winds for most of Gulf side Florida, where we actually had negative tidal surge going on. And so you also think what's happening offshore. That happens a lot of time, even on the eastern United States, where you get offshore winds, and really strong offshore winds causes cool water upwelling. So that, like you said, it starts offshore and works its way into the coast.
Yeah, so I got our next question here. Some awesome information, because I'm learning a lot about the red tide myself. We often associate, especially us up here, red tide with Florida. Does it pose an effect to the coastal Carolinas? From South Carolina coastline up across the Outer Banks.
It's a really good question. So only 8 times since the 50s has Florida red tide gone to the east coast of Florida. Even only twice has it made it above Florida, and one time it made it to North Carolina. The other time it made it all the way to Delaware. So it's a possibility, but it would be unique.
Awesome. That's good information.
Scotty, were you up next?
Yeah, I was trying to unmute myself. So Tracy, how often does the red tide happen? I know we're talking about, but is there a peak season that we see more growth, or is it all year round? What's the peak season for the red tide?
So the typical season for red tide is late summer, early fall till winter. That's typical, but red tide can happen any time of year, as we've seen. Now, that being said, the question is, with climate change, will this season shift? And if it shifts, will it shift into the rainy season, causing longer blooms to be a normal thing? We don't know the answer to that yet, but that is something that we are looking into.
Okay, I guess the next question comes to me, and you talked a little bit earlier about brevetoxins, right? So neurotoxins. And I have a lot of friends down in Florida that were reporting on social media outlets and telling me, hey, look, there's issues here, and sending me pictures of beaches being closed in, say, Fort Lauderdale area, all the way up the eastern coast, near Cocoa Beach, Florida. Also over towards Fort Walton, the Tampa Bay, Sarasota area being the main concentrate for a lot of these brevetoxins. But folks were talking about respiratory issues they were coughing a lot, their eyes got watery, blurred vision, things like that. And talk a little bit about the neurotoxins, what they're doing to you, that you may only see the outside symptoms. Is there something deeper going on that we need to be concerned about?
That's a really good question. A lot of people ask what the long-term effects of brevetoxin exposure are. And there's a lot of unknowns. There are some supporting evidence with other species that it couldn't possibly have some kind of immune impact long term. However, those impacts haven't been defined yet. And a lot of the reason is humans haven't been exposed to it in a chronic way enough to connect to any kind of disease or illness with brevetoxin specifically, because there are so many different factors that come into play. And we have these blooms for months at a time, years at a time, weeks at a time. And so people aren't always exposed to that every single day. So I think it's hard to make that link unless you're doing an exact study. So I think moving forward, a lot of people are looking at doing lung studies or different parts of the body where you can use a fabricated organ and see how the toxin affects that organ. I know that I was talking to the University of Florida about doing something like that. And I think that they're doing it with microcystin now. So we'll see what happens and where funding goes, and if that will be a possibility to really hone in on those long-term possible impacts.
Yeah, I've heard it's pretty dangerous even just to experiment with that stuff. Is that what causes it to be like this? Or is this a defense mechanism, or is it just the nature of it?
Yeah, I mean, like a lot of plants, they can defend themselves. And so we're not sure what Corynea brevis's role was in the ecosystem to where they developed this mechanism. But that's the one of the theories is that it is a defense mechanism.
Doing with a quick technical thing there, so if people watching live maybe just dropped out for a second, welcome back as we continue our conversation about red tide. Tracy, what I wanted to ask is a little bit more about the mobile app. What's it called? Where can people find it? And what type of public data have you been receiving from it?
Good question. So we do have mobile apps. They're free on iTunes and Google Play. CSIC, C-S-I-C, get it, CSIC. But it's Citizen Science Information Collaboration. We really forced the acronym. But that is available from Google Play or iTunes for free. And then we also have the BCRS, which is searchable by Beach Conditions Reporting System, BCRS, or MOTE, M-O-T-E. And that is available for free from Google Play and iTunes as well. So they are available, and we've been getting a lot of information. So the BCRS and CSIC both have a contact us button where people can actually send us emails, and we get a lot of valuable information and additional information on reports from beaches not necessarily reporting that day. So it's really been very helpful in having us figure out where to take samples, how to alert the public, how to communicate with the public. And it gives CSIC, it empowers the public. It gives them a platform to report and voice their experiences. And with BCRS, it allows people to stay connected with the scientists and understand what's going on with the actual effects at the beach.
And Tracy, before we start to wrap up our conversation here as we approach the 9 o'clock hour, I want to give you opportunity. Is there anything that we haven't really discussed that you want to? And I want to also put that with this: how can we reduce the threat of red tide, or is there a way that we can totally eliminate it? So maybe there's something we haven't covered. I'd love for you to jump in with that, but also kind of one of our closing questions. Is there any way that we can reduce this or maybe even eliminate it altogether?
Yeah, that's a really good question. As far as eliminating it altogether, because we're not sure what kind of role it plays in the ecosystem, a lot of scientists actually hypothesize that it plays a really important role in resetting the ecosystem, keeping out invasive and exotic species. So getting rid of it altogether, it's pretty much impossible because, well, it's microscopic. Like if I had a vial like this, it would look completely clear and there could be hundreds of thousands of cells in there. It's microscopic and it's a huge body of water, which has made researching Florida red tide so difficult. But if we were able to get rid of it entirely, I think that if we got to that point where we knew that, we would be able to answer the question of what role it plays in the ecosystem. So that's just a question that I can't totally answer. But as far as reducing it goes, now we know that it's native, it's been happening every single year, but we also know that if a bloom is close enough to shore to utilize surface water nutrients, it very well may. So there are many things that we can do right at home. You know, I'm a stormwater engineer and So low impact development and hydrologic restoration are kind of like my passion. So reducing our individual nutrient load to the natural water systems, as well as, you know, improving on any regulations for agricultural lands or new developments, for example, are keys for reducing that nutrient load that can possibly be playing a role in the intensity and duration of red tide blooms. Now, we haven't found a correlation between any one stream or river network water outfall and Florida red tide bloom duration or intensity. However, we have found a correlation between total riverine flows and Florida red tide bloom duration, which means that our nutrient loading is coming from so many different places, from many different origins, and they're coming to our coastal waters, and it is potentially playing a role in Florida red tide blooms. We know that. Now, what I personally am looking to do moving forward is filling in the data gaps so that we can have a statewide integrated groundwater and surface water model to prioritize what projects we want to, or we need to, or should look at first on retrofitting or improving our BMP, best management practices, or you know, kind of diverting or reducing the nutrient loading to natural water bodies. And I could go more into that and what we can do in our own homes too. I can talk about that stuff all day, but I don't know if we have time for that.
Sure.
Well,
Yeah, I would love to hear, you know, that'd be great. Let us, what can we do in
Okay.
our homes to help? Because we definitely
Yeah.
want to promote that and how we can make things better.
Awesome. And it's important to know that, you know, reducing the nutrient loading and to the surface waters, the coastal waters, wouldn't eliminate red tide blooms. You know, I don't want to give people false hope there, but it can very well eliminate a lot of the freshwater cyanobacteria blooms that we see. So regardless of the role it plays in Florida red tide, those freshwater blooms are a big problem as well. So right at our own home. So right now you might notice that rain falls on your roof, it goes into your storm drain, travel down your driveway into a pipe network. A lot of people don't really think about where that pipe network goes, but it does go into our natural water bodies. So disconnecting that impervious surface, and my dissertation research was actually on doing exactly this. And what I found is that disconnecting that impervious surface was the #1 way to restore the hydrologic cycle. So disconnecting that, so taking water that goes into your downspout and putting it into a cistern or into a rain garden or biofilter or infiltration trench, or a number of other tools that allow that water to actually infiltrate into the ground, allow for that biological, physical, and chemical degradation of pollutants. So anything that does that, implementing pervious pavement and pervious pavers where possible, can make a huge impact. Green roofs, eliminating, you know, fertilizing during rainy season, or using fertilizer at all through using native plant species. All these things are really important and make a huge difference. And you might not think that making a difference just at your own home makes a huge difference to the watershed, but it does, because if every single person did that little bit, it would make a huge difference. And a lot of people, you know, there's one thing that I should probably say, and it's kind of off topic a little bit, but I want people to understand the role of nutrients and the difference between nitrogen and phosphorus. So nitrogen and phosphorus, there needs to be a certain ratio for production to happen. So a lot of people ask us why we're not focused on phosphorus when we're talking about Florida red tide. And the reason is because there needs to be that ratio. And in marine systems are nitrogen limited, meaning that there's plenty of phosphorus around. So the nutrient that we're focused on for that production of Florida red tide is nitrogen. Now with freshwater systems, this is the complete opposite. There's plenty of nitrogen around, and it's phosphorus that's a limiting factor. So for freshwater blooms, like what I was working on for my dissertation, I was worried about phosphorus. Now Lake Okeechobee is a little bit different. It goes both ways because we have so much natural phosphorus in the state of Florida. So it can be nitrogen or phosphorus limited depending on the time of year. So I just want people to really understand the role of nutrients and the difference between nitrogen and phosphorus and what we can do to, for example, phosphorus is really easy to remove because it's adsorptive. It's hydrophobic. It wants to attach onto something else. So we can have filter media and infiltration trenches to remove that phosphorus that will prevent those freshwater cyanobacteria blooms from producing. Now, nitrogen is a little bit tougher because it needs that biological degradation. So it takes time in detention. So ponds and detention ponds, retention ponds are better for nitrogen removal.
Very interesting. Thank you very much for all that information, Tracy. We appreciate all of your expertise on the topic tonight. I wanted to give you some time as we're kind of rounding the 9 o'clock hour to promote yourself. Tell us how we can find you, any productions you're working on. We understand you were on Mythbusters last season and you're on another show now. So give us a little bit of insight about what you're doing right now with production shows and talk about yourself some.
Yeah. And sorry, guys, I was like super nervous in the beginning. So I know I stuttered a lot, but I'm good now. You can find me at Inspector Planet on Instagram, Twitter, Facebook. And I was on Mythbusters Research. It was a lot of fun. I got to try to paint a room with C4 and I got to drive a car and press a button that took the passenger seat right out laterally. It was pretty awesome. And I have some videos on that. If you guys contact me on social media, I can give you like a reel of all the cool stuff that we did on Mythbusters. But now I'm on, I do a segment, animal myth busting segment on Animal Outtakes, which is on ABC. And this week I'm on an episode of Awesome Planet, which is on Fox. And I'm talking about red tide and using biofilters to actually remove the red tide toxin and cells from the water column. So using native species filter feeders to help alleviate some of those red tide effects. And I'm working on a few other things, but nothing's like set yet. So I can't really talk about it.
Very good. Very good. So you're on Facebook as well, Dr. Tracy Fanara, and then are you on Instagram as well? I missed if you said you're on.
Yeah, Instagram's my favorite.
Okay, just as your name on Instagram?
Inspector Planet. Yep.
Cool, okay. All right, good deal.
Yeah, Inspector Planet on Instagram, and I do a lot of Instagram stories. And if you ask me a question or tell me to talk about a certain topic, I will do that. I love Instagram stories.
Awesome.
One thing that I wanted to leave everybody with is a lot of people are asking what we're doing about the Florida red tide bloom. And now we're looking at mitigation strategies to actually, it's kind of like wildfires. They have to happen, they're natural. But when they get out of control, that's when people intercede. And the question is how to intercede with Florida red tide without posing long-term effects on the ecosystem. And we're looking at a number of different strategies right now, and we're starting our preliminary trials coming up. So hopefully we can figure out a way to alleviate those symptoms, at least in the canalways where people don't have the choice to actually leave like you do when you go to the beach.
All right. Well, thank you very much. We're going to go ahead and transition back to James. We're gonna get some final takes to the show here, some roundtable talk and a couple of other things that are interesting topics here. But feel free to join us and stay on until the very end, and we'd like for you to. And folks, thank you all for watching. If you have any further questions, please feel free to put those in, and we'll make sure to pass those on to Dr. Fanara for after show responses. And I'll go ahead and pass it back to you, James.
Thank you, Shade. Thank you to Dr. Tracy as well, too. That's right. We will have more show coming up. We're going to take a brief break. We wanted to share this video with you from NASA. As you may have watched live right here on the Carolina Weather Group, NASA has landed the first American-made spacecraft on Mars since 2012. The InSight lander landed there earlier in the week, and we wanted to show you exactly how it was done. Take a look.
Although we've done it before, landing on Mars is hard, and this mission is no different. The process to get from the top of the atmosphere of Mars to the surface we call entry, descent, and landing, or EDL. It takes thousands of steps to go from the top of the atmosphere to the surface, and each one of them has to work perfectly to be a successful mission. The process starts well above the top of the atmosphere of Mars. The cruise stage faces the sun. It also has its radio antenna, which faces Earth. But now we don't need the cruise stage. Its job is done. The next step, just 7 minutes before arriving to the top of the Mars atmosphere, is to separate the cruise stage. Before you hit the top of the atmosphere, though, the space capsule has to orient itself so that the heat shield is precisely facing the atmosphere. Now the fun begins. The vehicle is moving at nearly 13,000 miles an hour, but it's hitting the top of the atmosphere at a very shallow angle, 12 degrees. Any steeper, the vehicle will hit the thicker part of the atmosphere and it will melt and burn up. Any shallower, the vehicle will bounce off the atmosphere of Mars. At the very top of the atmosphere, it's about 70 miles above the surface of Mars, and the air is starting to get thicker and thicker and thicker. As it does that, the temperature on the heat shield gets well over 1,000 degrees centigrade, enough to melt steel. Over the next 2 minutes, the vehicle decelerates at a backbreaking 12 Earth Gs, from 13,000 miles an hour to about 1,000 miles an hour. At about 10 miles above the surface of Mars, a supersonic parachute is launched out of the back of the vehicle. 15 seconds after the parachute inflates, it's time to get rid of the heat shield. 6 pyrotechnic devices fire simultaneously, allowing the heat shield to fall and tumble away from the vehicle, exposing the lander to the surface of Mars. 10 seconds after the heat shield is dropped, 3 pyrotechnically deployed legs are released and locked for landing. About a minute later, the landing radar is turned on, sending pulses toward the surface of Mars as the vehicle starts to try to measure how high it is above the surface and how fast it's going. At about a mile above the surface of Mars, the lander falls away from the back shell and lights its engines. And very quickly, the vehicle must rotate out of the way so that the parachute and the back shell doesn't come down to hit it. The last thing that has to happen is that on the moment of contact, the engines have to shut down immediately. If they don't, the vehicle will tip over. So if all the steps of entry, descent, and landing happen perfectly and we are safely on the surface of Mars, we'll be ready to do some exciting new science.
Welcome back to the Carolina Weather Group. I'm James Brierton in Charlotte. We have our whole panel, Dr. Tracy, sticking around. We're just past the 9 o'clock hour. We're going to spend a few minutes here doing our weather roundtable, wrapping up tonight's show, starting with a viewer feedback from tonight's interview. Rick writes in that he was recently kite surfing a few weeks back. He was at Hutchinson Island. The red tide count was low in that particular area, but he noticed after going into the water and back to his car that he had a little bit of a respiratory irritation and thinks that maybe he did, in fact, come in contact with some of those toxins. So some good information, Rick says, that he learned tonight as he will be returning to the beach and heading back out into the water. Some good information to keep in mind. So, Dr. Tracy, viewers enjoyed everything you had, and we appreciate it as well, too. I know a lot of viewers watching right now from all over the Carolinas, especially in the western half higher elevations, are dealing with an early introduction to snow in winter, but everyone's kind of got those cold temperatures, and that's a little bit what we want to talk about. We're going to start backwards in time, work our way through what's happening tonight, and close things out with Chris Jackson's own winter outlook. But let's start with Scotty Powell. Scotty, I know where you are in the foothills there in Morganton. Not only did you guys have a taste of winter in the last 24, 48 hours, but actually it started for you last weekend.
Friday night into Saturday, we had a brush with winter weather. A pretty significant ice storm occurred in select portions. This wasn't a widespread event. The North Carolina mountains obviously got some ice, but also the foothills of North Carolina, McDowell, Burke, Caldwell, Alexander, up into Rutherford and Cleveland County. It was kind of the Interstate 40 corridor, and we saw what we thought was just going to be a little significant or a little ice event. Maybe 3 or 4 hours of temperatures right out or below freezing. They give us a light glaze, but that definitely didn't happen. We kind of, I don't want to say blew the forecast because we was calling for ice, but it was a little bit worse than what we thought. The temperature stayed around freezing or below throughout the duration of the rain. And so I woke up Saturday morning to a 1/4 inch of ice here at my residence. Other places throughout the county saw up to 3/10 to 4/10 of an inch of ice. Numerous power outages. I was driving around town the past few days where I live, and it kind of looks like a tornado's hit here. There's so many trees down. A lot of trees that were knocked down from the ice. We still have a little bit of foliage on the trees as well from our leaf season. So I think that also added just a little extra weight. So I wanted to share with you just some of the pictures that I accumulated throughout the event. This was on my Twitter page, and my computer is freezing up. There we go. Just bear with me 1 second.
Is that a weather pun? Your computer is freezing up?
It's freezing. Yeah, it is. It's saying, I hope you can still hear me. It's saying Google Chrome is not responding right now. So I know Ricky saw some snow earlier. So Ricky, I want to toss it to you, and maybe by then I can get my pictures on.
All righty. Yeah, we did see it. It was our first kind of significant Northwest flow event for the season. I'll tell you what, it produced a lot across Southwest Virginia. Some of the mountains of Wise County and parts of Russell County got a good amount of snow. And Boone especially got a good amount of snow from this, where the mountains upsloped it there on the Tennessee-North Carolina state line. Trade I think we had a report of 6 inches in Trade. May have been in a drift, but still some significant totals in spots. Other spots not getting a whole lot. It was hard to find snow this morning in Elizabethton and Bristol area. But boy, temperatures have been cold. We had some 20s, and tomorrow is finally one of our warmer days. We're going to swing back to 60 degrees this weekend with maybe even a thunderstorm in the mountains. So that should be fun. I was seeing a post earlier, talking about how we've seen these temperature swings in December and in November. And to me, I kind of want the temperature swings if we want a snowy winter, because otherwise you get into last year, we get in the situation where it's January and we've got temperatures in the teens and 20s, but no moisture to work with because the air is just so dry. So hopefully we keep these temperature swings going, maybe line them up with some cold air, and get some snow going this way, Scotty.
Yeah, that's right, Ricky. Definitely looking forward to that possibility. So I think I've got my pictures up now. Here was some of the ice that accumulated Saturday morning. As you can see, a lot of folks seeing this freezing rain. This was a scene that many people saw in the foothills of Western North Carolina. A lot of trees down, several people without power for, I think they didn't get their power back till sometime Monday. So it was a very, very icy start to the weekend, but thankfully it all melted away. Folks got their power back. But as Ricky was talking about, we do see kind of that little warm up, but that's what we want to see if we want to see some winter storms around here. And I always say, if it's gonna be cold, we might as well have some snow to play in. So that was the week that was here in the foothills and the mountains. So James, I will toss it back to you.
Scotty, thank you very much. Let's bring in Jared. He's in Charleston, where they're getting a bit of the cold temperatures tonight too.
Yeah, I mean the freeze it's definitely passed through Charleston all the way, all the way south. Growing season's over as of this morning. First time in 301 days that we have had a freezing temperature in Charleston. Now, I put that in some context. It's the third longest stretch that we've ever had temperatures above freezing. And it's hard to believe because we started this year under 6 inches of snow, which never happens. But from the 1st of February to today, the 300-day run, and that's it. So back into the freezing zone. Second place, 311 days, was February 28th, 1994 to January 1, 1995. And then the top one is 315 days, January 26, 1992 through December 5th, 1992. So that's pretty rare. We usually get usually a little bit sooner, and it's very rare for us to go through any sort of February without any sort of freezing temperatures. So been kind of it's been rather warm this year. It's been rather warm this fall. And now it's just a flip. That's a pretty good little trough that's been digging down and blasting a lot of cold air, all the way down into Florida, where 50 degrees feels like -50. James?
I can feel the warmth
Yeah,
from the picture behind you, though.
Jared, I was going to add also our wind chills were down this morning too. We had some pretty high wind speeds up near 20, 24 miles per hour. So wind chills across the harbor were down in the low to mid 20s, which, I bet that there was a few people out, for of course, fishermen that go out, and then inland mid 20s for the most part. It'd be less than that tonight with less winds. But also Dave Williams from Channel 4 nailed it pretty good. Schizophrenic weather, whereas we're, in freezing temperatures now. By this weekend, we're probably going to be getting to record warmth.
Yeah, we just, it just keeps, we can't settle into something called fall, right? Like fall, it'd be nice if we had a fall. I'm going to pull up a graphic real quick, and then I'm going to get out of here before James yells at me for going over time. But check this out, okay? Like this is fall. This is the beginning of fall. Look at it. We have all these highs trending up on this side, and then boom, down, and then up, and then down, and then so you have this roller coaster. We want to be kind of in the middle. We want to be in the brown in the middle. It's the one time that you want to be in the brown, right? It's like we want to be in the middle here, but we keep going up and down and up and down. It's just a roller coaster, man. I do not do roller coasters.
It's bad for cold and flu season too. It just makes it worse.
Tell me about it. I started the show off the air because I was sneezing my brains out. So there you go.
Show title right there, sneezing your brains out.
If that doesn't get clicks on YouTube, I don't know what will. I think Chris Jackson actually has the outlook for us. Charleston, from Charleston to Columbia we go, and South Carolina weather. How are we looking, Chris?
Well, I mean, everybody's been pretty much nailing it on the head. Ricky said it got a bunch of snow up around the North Carolina and Virginia mountains, and I think a lot of that's going to continue going forward. I'm going to share a few graphics with you guys. If you follow me on my Facebook page or the Carolina Weather Group, you've probably seen these graphics put together. But some of it's from NOAA. But we have our 2018 to 2019 seasonal outlook as far as climate and precipitation is concerned, and the official NOAA precipitation outlook is for above average precipitation in the southeast, with temperatures right around average, through at least February of 2019. To summarize, you hear a lot about El Nino, and El Nino is really important in how it affects the weather across the southeast. You get a more active southern branch of the jet stream, bringing Pacific moisture in with a lot more southern storms. So, with the El Nino watch being issued, they're saying that conditions are pretty neutral right now, but going into December through January, they're expecting El Nino conditions to develop. And what that means is basically you have warming of the equatorial Pacific waters in the central and eastern Pacific relative to normal. So you get warmer than average sea surface temps across the central and eastern Pacific, and that really it helps to influence the southern track. And here's another graphic just kind of showing that. You hear the Pineapple Express, and that's kind of what that southern branch of the jet stream is. And what's really important is that, once we get into January, late December into January, you start getting these cold shots of air with the the polar jet stream. And if you can get these systems to phase together across the Gulf of Mexico, that's when you get our big snowstorms across the southeast. And with that, our earliest snowfall that we ever had in Columbia was November 1st, 2014. And our largest 24-hour snowfall was 15.7 inches. That occurred in the blizzard of 1973. Just a couple of little facts. And, our top 10 South Carolina snowfall totals by year, 18 inches in 1973. And our 10th was a modest 4.3 inches. So, any kind of significant snowstorm that we get across, South Carolina, if that were to happen, could be a top 10 type storm, which is, I think, going into, especially January into the middle of February, definitely possible.
And Chris, those Miller A's are generated from that subtropical jet to the south. So it'd be interesting to see how much moisture is pulling across from the Pacific into the Gulf of Mexico to generate some of those lows.
Absolutely. And, you get that Miller A type storm where you have one centralized area of low pressure that moves across the Gulf Coast and basically the Florida Panhandle over Jacksonville. Then, as it ramps up the East Coast toward the benchmark off the coast of Massachusetts, the storms bomb out. They become basically winter hurricanes. And that's where you get your prolific blizzards in Boston with 3 and 4 feet of snow sometimes. So I think really going January, really into March for the northeastern part of the country. It's going to be a really snowy, it probably going to be the best winter we've seen since 2010.
Bring it on is what I say.
Okay, you heard it. You heard it from Chris. He's calling it.
Hey, I'll put it out there. I said it.
I personally hope that comes true. So again, we want to thank Tracy for joining us tonight. Make sure you go follow her on Twitter and Instagram and Facebook. We'd love for you to go do that and let her know if you have any questions about the Red Tide. Looking ahead to our schedule coming up next week, we have Mark Sudduth on. He's from hurricanetrack.com. A lot of you folks, especially if you're into the weather industry, if you really like weather, you've probably heard Mark's name before. He's going to be joining us, talking to us about his hurricane chases with Hurricane Florence and Hurricane Michael. So Mark will join us next week. And then on December 12th, we're going to have Heather Hollenbach. She works for NOAA. She is actually one of the hurricane hunters. She flies into these hurricanes. So Heather, I think, flew into both Florence and Michael. So Heather's going to join us and talk about what else she does as they fly into hurricanes. And then as we close out the month of December 19th, it's an open mic night. So guarantee there will probably be snow on that day or on that week or something like that, because when we do these open mic nights, it always seems like we have some kind of crazy weather that happens. So that is how we will round out the year 2018 here at the Carolina Weather Group. So as we close tonight, I wanted to let you know, look at this view right here. This is from the International Space Station. This is how they celebrated Thanksgiving. We hope you enjoy the video, and we'll see you back here next Wednesday night for another edition of the Carolina Weather Group.
Hello down there on the good Earth, and all the best from the International Space Station. I am Expedition 57 Commander Alexander Gerst, and next to me we have Serena Onion Chancellor, Flight Engineer from NASA. Well, today is a special day, especially for me, because I've already had the honor several times in my life to spend a Thanksgiving together with an American, which always makes it an especially great experience. So tonight we will have a Thanksgiving dinner up here on the International Space Station, covering 3 continents together with our Russian colleague Sergei Prokopyev. And this is our turkey.
Like Alex said, this is what we're going to be enjoying this evening. We've got everything from turkey to candied yams to stuffing to special spicy pound cakes. So we're very excited. Thanksgiving is a time to spend with those whom you love, whomever that might be. And so we'll be enjoying this meal together, but then also calling our loved ones back on planet Earth. And so we hope that whether you are at home or deployed around the globe, that you are able to find some time to spend with friends and or family. So definitely from the crew of Expedition 57, from our home to yours, we wish you a very happy Thanksgiving.